Let's move on to the next subtopic. Before we start, I need you to key in to your browser this link on the top here, gg.gg, not the gg that you always say that, /J0YV1. Okay, J0YV1. So inside there is a set of questions that is related to the video that I'm going to play here. Okay, so while you view that, you answer those questions. It will help you in understanding this subtopic. Okay, so let's play that. So it's showing you two waves when they meet at a point. Okay, and then give you the result in the middle, and you can see the two pink arrow here in the middle of the slide, the two pink arrow there. So that you place a pen across them, aligning them, and then you can it can help you to answer the question later. All right. So what you see in the video just now is actually a type of waves called the stationary waves. So as compared to the previous topic, progressive wave, where you see the profile moving, stationary wave, their profile don't travel along with the propagation of the waves that form them. So they will just stay in the middle there, and then they will show you some oscillation. Okay, so that type is called a stationary wave. So a very good example is a string that you plug on a guitar. Okay, as it vibrates at a certain frequency, it's actually forming a stationary wave. So let's see how that form. So first of all, you need to have a source of disturbance that you send the wave pulses to a fixed point. Okay, as shown in this picture here. So that's a fixed point that the pulse is traveling there. We call it incident wave. Okay, incident wave, you can write that down. Incident waves, if it's a wave now, okay, in this example here is a pulse, and then this pulse is going to get reflected. Okay, so as it arrives at the fixed point here, it's going to turn back. So as it turns back and travel along the direction where it come from, then another pulse is sent. Okay, so then another pulse is sent. So this pulse, these two pulses, they are going to meet, okay, at certain points, and the thing that happened is they are going to form a stationary waves if it is possible. Okay, so but we have to make sure that these two pulses, the incident pulse and also the reflected pulse, they must be of the equal speed, frequency, amplitude, but opposite in direction. Okay, so that's the first criteria of a stationary wave. So if they have successfully formed a stationary wave that is very significant, then there will be some points that are categorized into a particular name. So that is called the antinodes and nodes. Okay, antinodes and nodes. So what is antinode? Antinode is a point with the maximum displacement. So that is this point here. Okay, it has the highest among all those points along the spring. Okay, this one is the highest one. And then we also have points that is zero amplitude, as in zero displacement. That's these points here, these 2 points here. It's called the node. So earlier in the video there just now, you actually are asked to find the number of points that have zero displacement and number of points that has maximum largest amplitude, right? So that's the A and the N here, the antinode and the node. Okay, so I hope that you count correctly. If not, then you can try again, because answer already given to you. Okay, so you need to understand and describe in words how a stationary wave is formed. Okay, so those things that I have said just now. Okay, so another thing regarding this node and antinode is that the antinode must be, because those waves as they meet there, right, they must be in phase. Their oscillation must be such that they are in phase. Okay, when one is at the amplitude, positive amplitude, the other one must be at the positive amplitude. When one is at the displacement of 1 cm, the other one must be at the displacement of 1 cm when they meet there. Whereas node is, they must be exactly in antiphase. Okay, when one point arrives there at a trough, the other one must arrive there with a peak. The next moment when it arrives there with negative 1 cm, the other one must arrive there with positive 1 cm. Okay, so that's what it means. So later we can see some animation, yeah.